Now let's consider the column. Okay, HPS column is expensive, and they are almost a packed column. Okay, the column case is made of steel or plastic. Yeah? The length is not very long. It's 5 to 30 centimeters, and the inner diameter is 1 to 5 millimeters. Okay, and it is expensive and easily degradable by dust or particle in solvent. So you need extremely pure solvent. Okay, and you need the to be very careful not to contaminate this HPLC columns. Okay, and those dust or particles in solvent, and by they are contaminated by irreversible absorption of impurities in solvent. So extremely pure solvent, which is called HPLC grade. Okay, is needed. To protect the main column, put a replaceable guard column here. Get that? This is the main column. Okay, this is the main column, and the main packed column, and right, uh, the before this main column, you put this guard column. Then this one, this is the entrance of your sample of and this guard column now, the sample pass first through this guard column, and then in the guard column, the dust or some particles are trapped in this guard column, right? And then this guard column, may be replaced, okay, and the chip, yeah, this idea. And the heating column, if you heat column, uh, will decrease viscosity of a solvent, and it reduce the required pressure, and flow rate will be faster. Okay, and so it will decrease retention time, but improves resolution. Okay, therefore 10 degrees C higher than the ambient temperature is better to use. So here, usually in gas chromatography, we do the temperature programming of the column. Yeah? In other words, the column is in oven, right? GC oven. So the oven temperature usually is programmed. Yeah, programming to from the low temperature to a higher temperature. Okay, but in HPLC, the temperature program is not usually done, but instead, the the eluent programming is usually done. Solvent program, okay, you will see soon. Yeah? But the column temperature is usually maintained 10 degrees C higher than the ambient temperature. Okay, it's important. Fine particles and strongly adsorbed solutes are retained in the guard column. Okay, here this is a kind of protection column, which is periodically replaced, yeah, when column pressure increases or after a set of number of injections or time in service. Okay, so now if you use over and over, and some solute fine particles are trapped here, and then uh, you need more pressure, higher pressure too, the flow, yeah, your mobile phase. Okay, in that case, there is a time to replace this guard column. Okay, so it is good to periodically replace the discard column with a new one. While guard columns make sense with 10 to 30 centimeters long chromatographic columns, many people do not consider a guard column to be cost effective for 5 centimeter column. Okay, if this main column is long enough to 10 to 30 centimeters, then guard column may need it. But if this main column is short, maybe 5 centimeters short, okay, and this guard column is also expensive, right? and so that's why many people do not consider a guard column to be cost effective for a 5 centimeter column. Okay. Well, let's consider now the stationary phase. Most common support. Yeah, this stationary phase is support. Okay, must be highly pure, spherical, microporous particle of silica. Usually, silica is used. Okay, this is the same image of 4.4 diameter, micrometer diameter, microporous silica. Okay, look at if you closely look at this one, you see this surface is highly porous. Okay, and this also this support, yes, this stationary phase also must be very pure, highly pure. Okay, the particle size must be very uniform. Okay, and then each particle must be a spherical shape. Okay, and since this particle size is very small and it is highly porous, the surface area is quite large. Each is up to several hundred square meters per gram, right? They usually we express the surface area per gram, yeah. And the silica is usual uh, the pH less than 8. Okay, for separation of basic compounds. Okay, pH maybe higher pH, yeah, pH 8 to 12, polymeric support, polystyrene, yeah, may be used. Okay? Yeah, this is the structure of highly porous silica. Okay, the silica is SiO2. So SiO2 now is interconnected by in three-dimensional way. Okay? And then surface. On the surface, there are a lot of uh, this OH group. Yeah? This is a bisinol silanol groups. They are called bisinol silanol groups here, right? Um, so they are hydrogen bonded each other. And when one silicon atom have has two this OH groups. mm, since silicon, yeah, silicon OH, this is silanol, right? And COH is alcohol, right? This is called silanol. And one silicon atom has two silanol groups. They are geminal, okay? Geminal silanol groups. Yeah? There are many silanol groups, and also this one. This is a siloxane bond. Silicon atoms are connected by oxygen. This is a siloxane. Okay, and this is expand. This is the this one is easily base hydrolyzed. This one. So to avoid, yeah, to minimize, base hydrolysis, and this structure is a little bit changed by introducing this ethylene group. Okay, between the silicon and silicon atoms. Okay, this structure is base hydrolysis resistant. Okay, and usually the particle size is less than 2 micrometers, and surface density of silanol is 8 micromole per square meter. I'm sorry, this is square meter here. Okay, and so this one, this silanol group, this proton may be deprotonated at the higher pH. So protonated at pH 2 to 3. Okay, so beyond, above pH maybe 3. Yeah, this the surface is negatively charged by deprotonation. Okay, yeah, this one. When pH is greater than 3, silicon oxide strongly retain the protonated base. Okay, when this is deprotonated and the surface is negatively charged, it now what statistically attract this positively charged compound, especially this amine, ammonium, alkyl ammonium. This one is positively charged at this pH, so it now strongly retained. Okay, on the surface of the compound, which makes a long tailing in the chromatograph. Okay. And different types of silica support may be used. Okay, there are types A, B, and C. Type A, silica support, it has more silanol groups. More silanol groups means more hydrogen bonding. So tailing in chromatogram. Okay. Type B is fewer silanol groups and less metallic impurities. Okay. Type C is even less silanol groups and 90% of silicon silanol is replaced by this one simple silicon hydrogen. Okay. Yeah. This is the this chromatogram was obtained with the type, let me see, type A silica, right? Which is highly hydrophilic. It has many OH groups, so it gives well good separation of compound 1, 2, 3, and 4. But this is compound 4, it and yeah, maybe yeah, all of these compounds, yeah. And then the compound 4 it shows in it very severe tailing, yeah, because of hydrogen bonding, right? Yeah, this one, the symmetrical peak is the best, yeah. A the 1, 2, and 3 compounds are also somehow is tailed, okay. But when the column is changed to type B silica, right? Uh, it has fewer silanol groups, yeah? And then this tailing disappeared. Okay, the one is doxapin. I don't know the, what that is. Yeah, this pramine, and aminotryptyline and tryptamine. Yeah, those things. So it is important to choose the right stationary phase, okay, which is silica support, to have a better, resolution and better shape, okay, and you know, within the proper, analysis time. This is type A. Since this compound, strongly retained in the column, so it the more time, yeah, longer time is required. But with column type B silica, yeah, separation is much better, and also analysis time is shorter. And bonded stationary phases, okay. For the adsorption chromatography, base bare silica is used. Okay, bare silica may be used, but for the better separation, you uh, you change bare silica surface with this kind of the molecules. Okay, that is called bonded stationary phase. Bonded. Okay, something is bonded. In this case, this silane is bonded to this on the silica surface. Liquid partition chromatography. Yeah, the bonded stationary phase is used. Okay. Okay, let's consider how to make this bonded particle. Yeah, this is a bare silica surface, okay, this way or this way, okay, and then here, this is a silane, yeah, and R is octadecyl uh, stationary phase, okay. With this one, the silica surface property is changed, okay, and this reaction is very is readily, yeah, readily, mm, is readily it can be done, yeah. And here, this one, H and chloride is removed as HCl, so this one has a very strong chemical bond on the silica surface. Okay, now this silica surface property is mostly governed by this R group. Yeah, here is R is usually octadecyl stationary phase. Okay, and if you use this type of silane, and then this one, two OH groups now bonded to this silicon. Okay, Yeah, either way. So here bidentate. Right. So this bonded stationary phase is by far the most common in HPLC, especially this algorithm is octadecimal. Okay? And bidentate octadecimal stationary phase increased stability above pitch 8, right? In this case, may be similar to this ordinary bonded phase, but now they are, silicon atoms are interconnected. Okay, so they are more stable in solution above pH 8. Okay, and this table shows the common polar phases. Okay, and depending on R, right, the this stationary phase maybe it can be polar and can be non-polar. Okay, to make the surface polar, you change this R to amino group, okay, or to this cyano group, or to uh, here diol group here 1 and 2, two diols, okay. And to make the surface non-polar, you change the R group to octadecyl. Is the most common one, and here octyl or phenyl or F5 phenyl. Yeah. So yeah, depending on this R group, yeah, surface properties can be controlled. Okay. Siloxane, yeah, this one. This is called the siloxane bond hydrolyzes below pH 2. Yeah, this one. This is a siloxane group. Is easily this bond easily hydrolyzed below pH 2. Okay, HPLC with a bonded phase on a silica support is generally limited to pH range 2 to 8. Okay, so when you run HPLC, you have to be careful of the pH. Okay, so if pH is too low, yeah, this siloxane group may be hydrolyzed. Okay, so usually the operating pH is between 2 to 8. Okay, uh, 2 and 8. Protection of stationary phase from this hydronium ion, this proton ion, by attacking bulky isobutyl group to silicon atom of a bonded phase. Okay, by attaching. I'm sorry. Yeah, so in order to avoid the hydrolysis, so this one is replaced by bulky group. This is what isobutyl group is much bulkier than this methyl group, right? So when you replace this group by these bulky groups, and then this stationary phase is more stable than this one. Okay, even in acidic solution. Okay, polar embedded group. So you make the surface polar. Okay, this is embedded because this polar group is embedded in this bonded group, right? Let's assume you have this one. Okay, this one. This is what amide group, yeah, on the surface, and then if you replace this one, oh, I'm sorry. Let me see. Yeah, this one, this amide, and although this part, right, this is quite non-polar, this it contains oxygen and nitrogen. Since oxygen and nitrogen electronegativities are quite high, so that makes the surface polar. This is called embedded amide near base of bonded phase. Okay. So embedded polar groups provide alternate selectivities from C18 stationary phases, improved peak shapes for bases, okay, and compatibility with 100% aqueous phase. Other non-polar stationary phases should not be exposed to 100% aqueous phase because they become very difficult to re-equilibrate with organic phase. Okay, so whenever necessary, you introduce these polar groups. Here, non-polar bonded phase with embedded polar amide group offers different selectivity from C18, yeah, this octadecyl group, yeah, has improved peak shape for bases, okay, and tolerate 100% aqueous eluent. Okay? So when you want to uh, the separated bases, yeah, it is better to use this one, embedded polar group, stationary phase. Okay, here is another topic, right? Another topic, which is monolithic silica columns. Here, monolithic is you have to understand that this term mono means one, single, lithic means stone. Okay, monolithic is one stone. It literally means one stone. Yeah, let's see this one. They are silica rod. Okay, let's imagine that you use silica uh, packed column for HPLC, but instead of using fine silica particles and pack them, uh, pack the silica the column with those silica particles, but instead you can use this silica rod. Yeah? This is silica rod. This is one body, so that is why it is called monolithic silica columns. Okay, this is this body, this rod you use as a column. Okay, this is enlarged view of this rod. This it has a lot of pores like a silica particles. Okay, it has a lot of pores, about 2 micrometer pores, and then this is much enlarged view, and you see in this case 13 nanometer pores. Okay, yeah. But what is the advantage of using this monolithic silica columns? Right? There are many advantages. First, the silica porous rod polymerized from silica precursors. Right? There are the method to prepare this monolithic silica the columns. Okay, there are several ways. For example, sol gel chemistry is the one. Yeah? Okay, so you make this whole column uh, at a as an one body. Okay, so let me see. So it increases the flow rate and retaining good separation. Column can be made very long. Yeah, this column made very long. Okay, and then with this monolithic silica column, separation will be very nice. Okay, uh, you have to increase the flow rate. Separation of isotopic molecules on a 440 centimeter long monolithic C18 silica column eluted with this one elution. Okay, elution. Uh, yeah, the solvent, acetonitrile and water. Right. The ratio is 30 to 70, by volume at 30 degrees C. Okay, so now you take this one, a very long monolithic, this is silica column, yeah, bonded to this octadecyl group. Okay, and then uh, it gives very excellent separation of uh, these compounds. Okay, let's say first, this one, the first one is thiourea. This is unretained. Yeah, retention time is 41.7 minutes. Wow, retention time is quite long, and this compound 2, 3, 4, and 5. They are or like this one. Okay, deuterium substituted the compound. Yeah? They are well separated except 4 and 5, and also this one at very high, long retention time. These compounds are separated. Okay. Okay, let's stop here.